Hello everyone, this is Stefie Stephen from India. I'm here to present the research work which is done in collaboration with Dr. Sunita K. Nair and Professor Ravindra Gettu. The rapid urbanization has caused a tremendous increase in the volume and magnitude of traffic. This is the reason for major distresses occurring in concrete pavements. Fiber reinforced concrete has been found to be a solution to arrest these cracks which are formed due to fatigue loading. Since the design of fiber reinforced concrete pavements involves both pre-peak and post-peak parameters, it is important to carefully look into it before considering it in design. So with this in mind, the presentation will focus on the incorporation of fatigue criteria in the design of fiber reinforced concrete pavements. The fatigue behavior of FRC can be looked in two lenses. One is pre-peak fatigue behavior, where the FRC element is subjected to fatigue loading in the pre-peak region and the corresponding SN curve is derived. Another is the post-peak fatigue behavior, where the FRC element is initially cracked under monotonic loading and then it is subjected to fatigue loading and the SN curve is derived. These SN models are available already in the literature. Now let's see how to use it in the design. The conventional design of pavement employs this methodology. The partial safety factor for dynamic loads of 1.6 is assumed for calculating the applied load. Then the allowable moment is calculated using the pre-peak and post-peak parameters, either using equivalent strength or residual strength. Then the design check is performed. As a design modification, it is suggested to use a fatigue reduction factor X and Y instead of using the dynamic factor of 1.6. X corresponds to the pre-peak fatigue model and Y corresponds to the post-peak fatigue model. So the X has to be multiplied with FL, which is the flexural strength, and Y has to be multiplied with equivalent strength. Similarly, for that design with the residual strength, X has to be multiplied with the tensile strength and Y has to be multiplied with residual strengths FR1 and FR4. However, the previous research finding says that the element with the crack openings more than 2 mm will fail suddenly under fatigue loading. Since FR4 is the residual strength at a crack opening of 3.5 mm, it has to be considered as 0 in the design equation. So the equation has been further modified like this and it will be used in the design. Here a concrete with 3 different dosages of hooked ended steel fibers is designed for a slab thickness based on this approach and compared with the conventional design. This is the case with designed with equivalent strength parameters, and this one is with residual strength. It should be noted that the one designed with residual strength seems to be more conservative. So the modified fatigue design seems to be more conservative and reliable, and it was also observed that with increase in dosage, the influence of fatigue on the requirement of thickness is decreasing. So now you know the importance of incorporating fatigue criteria in the design of FRC pavements. Thank you for your attention.